Hello everyone. In this video, I would like to talk about how to implement regression using Python and global gram cell prediction. First, I will introduce the regression. Many machine learning algorithms face syndrome bias variant. If the size of the training data is very bigger than p, which is the number of predictors, the least square methods tend to have least variance. And if the size of the training data slightly greater than number of predictors, least square method tend to be high variance. And other case E n is lower than P, the least square method should be not applied without dimensionality technique. The least square method can be linear regression, other regression methods like lasso, for example. So this is how why we use regression. Regression can significant helpful when deal with high variance. So the least square method we have this square method will minimize the minimum residual sum of square error, which denotes a RHS, which is calculated in the equation above. Equation here, which is the sum square error between the label which is the plot value, is the numeric value, and the predictor value within this. In this example, we call b times 0 is the bias term, and this is the loss function of the regression. Whereas here the lambda is tuning parameter and beta 0 is the bias term. These formulas have regression can reduce the high variance problem compared with the other least square methods. The other method that we have only like linear regression, we have only this part. So to update parameter, we use gradient descent algorithm, which I will mention later. But to use gradient descent algorithm, we need to calculate the derivative of the change respect to beta, which equal to this quantity, where here S is data matrix with dimension of m multiplied with k. K will equal to n plus 1 in case we use bias term. And the beta is the vector parameter which has dimension k multiplied by 1. And gradient descent method will update the beta vectors by minus x by the learning rate multiplied with the derivative of the change respect to theta. Next, we will move to the Python implementation of regression. I will implement the method fit for training the regression model. First, I Guess the information about the number of sample and number of features in the data matrix. A random initialize parameter by uniform distribution. And after each iteration, I calculate the radius of that parameter. Guess calculate the loss value, store it in the array. This is the function to calculate radius. First, we need to calculate the error, and we can calculate it by subtract between the register and the variable label, which can be equal to h dot to theta e dot to theta, which in the function theta, which is the w parameter. Then this is the loss get loss function. I use some handy functions from the NumPy library. Let's we move to the program Regression cell dataset. You can see here this dataset has many columns about the games. Each row is the data of one game with a cell on global. We have for each the game we have the number, the column platform, which indicate the platform this game can be run. You see Q or DS, for example. Years of release column, range of game, sport, racing, match, and the publisher, which is the company name who reduced the game, Nintendo, and we have the sales value for the in each region and the global. We have the Europe, Japan, other country sale and global sale. And the other column can support to predict the sales is critical, user call, user count, rating of game. Let's move to the regression step. First, I remove all the missing attribute record. Then remove non-popular game with either high number of global sales is lower than 30. Remove 1% quantile popular game by global sale. And only retain publisher and the level which has list 20 games. The year of release, rated core, rated count are normalized by standard scalar. Training, I train the model with 200 iteration with the learning rate equal to 0.01. And we can keep the modelให้converge after about 125 iteration. The model performance, I measure 4 metrics to evaluate the model's performance. The win means absolute error is equal to 1.1. The mean square error is 2.1. Root mean square error is 1.5 and root mean square log error is 0.4. Thank you everyone. Hope to see you in the next video.